Hello again. I hope you enjoyed the kata or the tutorial. You have already learned a lot of what there is to know about behavioral anomaly detection. However, in the next couple of videos, I will go into more details on a number of aspects of the features that weren't completely covered in the kata. In this video, I will give you an overview of all types of change points that you can detect with DataMiner. In the kata, you already saw two types that you can detect, the level shift and the variance change. Then in the exercise following the kata, you also encountered the outlier. In total, DataMiner can detect 5 types of change points. Next to the 3 that you already saw, you have the trend change and the flat line. Now, if DataMiner detects a change in behavior but could not categorize it as one of these 5 types, it will call it an unlabeled change point. Now, remember from the kata that a change point can be marked as anomalous or not, depending on how weird DataMiner considers the behavior to be. Now, each of these 5 types of change points, except the unlabeled one, can be marked as anomalous. And this depends on the historical behavior of the parameter and how severe the change point is. So for a level shift, for instance, this depends on the size of the level shift and the level it jumped to. For a variance change, this depends on how much the variance changes at the time of the change point. Now, I will go over all of these 5 types and give you a few examples of each of them. So the first one, the level shift, you already encountered in the kata. This is when a parameter remains stable around a certain value, then it jumps either up or down, and then it remains stable again for some time after the change point. So we already saw an example of this in the audio bitrate element in the kata. So as you can see here, let's go there, yeah. The level remained stable around 96 kilobits per second, and then it jumped up to 256 kilobits per second. And it remained stable there for a few hours. Now, if you zoom in here, then you can see some more details. So it says level shift, then from the level it was at before the change point, and then to the level it was after the change point. So here, 256 kilobits per second. Now, a more real-life example of level shift is the following, which was detected on our Zine system on the IMS-IX.net element. This element monitors the data throughput through the IMS-IX network through some public API. And this network is one of the main internet exchange points in the Netherlands. And as you can see, on the 22nd of November, there was a big drop in the data throughput. And this actually corresponded to a real problem that they had on their network at IMS-IX. And as you can see, DataMiner does detect this as a level shift. And as you can see from the dark color under the trend graph, it is marked as an anomaly. So this is an example of where anomaly detection in DataMiner can be used to be notified about a real problem. Another example can be found in the demo elements, here in the stalled events managed OTT element. So you know the drill, if you press generate data, some data will be pushed to this parameter. Now this parameter simulates the percentage of devices that reported stalled events in an OTT service. In an ideal case, this is close to 0, but as you will see, this was a case where there were higher values reported. So as you can see, indeed, it's close to 0 for a long time here. However, recently it jumped up. And as you can see from this bar underneath the trend graph, this was detected as a level shift and even an anomalous level shift. So that means that you can find this back in the suggestion events tab in the alarm console. Another example of a change point that we already saw in the kata is the variance change. So this comes in 2 flavors, the variance increase and the variance decrease. The variance increase is when a stable parameter suddenly becomes a lot less stable. So there is a lot more noise on the parameter. We have an example of this in the audio bitrate CBR-VBR element. So as you can see, this parameter first is relatively stable at around 96 kilobits per second here. But then it becomes a lot less stable, around the same bitrate value, but with a lot more variance. And as you can see here, a variance change is detected. This is a very typical example of a variance change that we see in the field, where a bitrate parameter was encoding first at a constant bitrate encoding or an average bitrate encoding, and then suddenly it changes to a variable bitrate encoding due to some configuration change. With typical classical alarm thresholds, it's very difficult to alarm on a situation like this, but with anomalies, it's actually very easy. Now, an example of a variance decrease can be found in the signal strength element that you used during the exercise. If you go a little bit back here, you see that here there is a period where there was a lot of noise, but then the parameter becomes a lot more stable all of a sudden. Now, a third example of a change point that you saw during the exercise is the outlier. This is when there is a very short spike or drop in your data of maximum a few data points. You can find an example of this in the following element, the TV watching element. So here this element simulates the number of devices that are watching TV at a certain point in time. As you will see, this will have a periodic behavior where there are more people watching TV in the evening and less people watching at night. And at some points, if you go a bit to the left here, there are drops in this data. So for instance, here there is a short drop in the data, and as you can see, this is detected as an outlier. Now, again, if you zoom in, you get some more details. So it shows the base level, so the level it started from, which is here around 37,000 devices. And then also the level it dropped to, so 9,500 devices here. Now, by default, no anomalies will be generated on outliers. Only after you've configured alarming on them, outliers will be generated. Another example of an outlier can be found in the signal strength element that you used during the exercise. The next type of change point is one that you didn't see yet in the kata-oriented tutorial. It's called a trend change, and it happens when the rate of increase or decrease of a parameter changes. So for instance, a parameter can remain flat for a long time, and then suddenly it can start increasing or decreasing. Or if a parameter remains is increasing at a constant rate, and then suddenly it starts decreasing, or it becomes flat, or it starts increasing at a more rapid pace. And that's when a trend change is detected. So I have a demo element which has one of these trend changes. So it's the server monitor element, and it simulates the memory usage of two DataMiner parameters at a time that there was an issue in an internal version. So it was captured by a central DataMiner that is monitoring several other servers that are running DataMiner, and that is used for QA. So let's have a look at this cloud gateway parameter. So as you can see, its memory usage remains flat for a long time, and then suddenly it starts increasing, which is a typical sign of a memory leak. And as you can see, DataMiner does detect this as a trend change. So if you zoom in, you can see a bit more details as usual. So here it says the rate of increase before the trend change. So that's here 4 kilobytes per minute, which is more or less constant. And then it gives the rate of increase after the trend change. Here it's almost 800 kilobytes per minute, which is a fairly rapid increase. All right, another example of such a trend change can be found on the Zine system. So it's very similar to the ones we have. So it's a parameter that is simulating the virtual memory usage of some media server. And here also you see that it remains constant for a long time, and then suddenly it starts increasing. Finally, we have the flat line. This was introduced in a later DataMiner version, so first in 10.2.5, a feature release, or in the main release 10.3.0. So this happens when a value that is fluctuating typically suddenly remains constant. Here you can also find an example on the same element, but now on the other parameter, the API gateway parameter. So as you can see here, typically this parameter, the memory usage of this process fluctuates a little bit. And if you zoom in, you see that from a certain point onward, it remains completely flat. And here we also have an anomaly that is detected, and it's called a flat line, and it displays the value at which it was flat. Note that if you look at this zoomed out and you would not have the anomaly, you would not necessarily see that something is wrong here, as it is not really clear that the parameter is still fluctuating here, but it remains constant at this point, and that really something anomalous happened. So this actually corresponded to a deadlock in this API gateway process. So it was really an issue. Finally, another example of a flat line can be found here on Zine system on the server monitor element, where you have a CPU parameter that's typically fluctuating a lot and then suddenly remain constant for some time. All right, then to close this off, a word on what happens when multiple things change at the same time. So we already encountered an example like this in the kata. If you remember on the encryption key requests element, if you look at this parameter, remember that it remained constant at a low value for a long time, or almost constant, and then suddenly it jumped up and it also started fluctuating a lot more. So in this case, two change points are detected, both a level shift and a variance change, because both things changed at the same time. Also on the Zine system, we have an example like that on the bitrate channel 2.1 parameter of the AMS encoder B element. That's another example of a bitrate parameter that changed from a constant bitrate encoding to a variable bitrate encoding. As you can see here, the parameter both jumped down and started fluctuating more. So also here, a level shift and a variance change is detected. All right, so that was it for the types of change points that DataMiner detects. In the next video, I will talk a bit more about how to create alarms on each of these types of change points.